Nothing to something. Take a good look around. Put everything you can see inside an imaginary but super powerful crushing machine. Plants, animals, buildings, your entire house, your hometown, even the country where you live. See it all get mashed into a tiny ball. Now, put the rest of the world in there too. Add the other planets in our solar system, the sun. Now put in our galaxy, the Milky Way, which includes between 100 and 400 billion other suns. Finally, add all the other galaxies in the universe. See all this stuff squeezed together into the size of a tennis ball. See it crushed even smaller than the dot on top of this letter I, until you can't see it at all. All those stars, moons and planets in a speck of nothing, and that was it. The universe began as a dot, too small to see. This dot was so hot and under such pressure from all the energy trapped inside it that something big was bound to happen. About 13.8 billion years ago, it did. It burst. You've probably heard of the Big Bang, the theory that tries to explain the beginning of the universe. But hang on a minute, the beginning? That's what's so hard to understand. If the universe had a beginning, what happened before the beginning? No one really knows. As you'll see, there are plenty of mysteries that even modern science hasn't solved yet. An unimaginably big blast of energy was released when the Big Bang happened. Next came the basic forces of the universe. Gravity is one of those forces. It is one that makes it is one of the most important because it makes all the stuff in the universe pull together. Can you look at what you're filming? Next came countless too tiny to see building bricks called subatomic particles. Think of them as miniature bits of Lego ready to build a whole wide universe. It's amazing to think that everything in the world is made out of billions of these subatomic particles created by the Big Bang. And that includes the furniture in your home and the hair on your head. About 380,000 years after the Big Bang, the universe had cooled down enough so that the subatomic particles stuck together to make larger, but still too tiny to see, structures that we call atoms. First, there was only one kind of atom, hydrogen, gathered into giant clouds of very hot dust. Then, after a long pause known as the Dark Ages, the hydrogen atoms crushed together and lit up the first stars. And that's what stars are. They're fiery balls full of atoms and energy left over from the Big Bang. Stars gathered together into galaxies of many shapes and sizes. Stars were born and stars died. More stars were born and more stars died. Then, about 4.6 billion years ago, about 2/3 of the way through the history of the universe, the leftover gas and dust cloud from an old burned out star crushed together and lit up to form a new star. And we care about this one the most. It's the one closest to our home, the sun. And our planet, along with several others, was formed at about the same time as the sun from a mixture of leftover dust and rock. This was our solar system. Our solar system is part of the great assembly of stars called the Milky Way. We are in one of the Milky Way's galaxy's arms, spinning around the centre of the galaxy at about 800,000 kilometres per hour. You can't feel how fast you're going because the whole solar system is travelling with us at the same speed. The early solar system was totally unsuited to life. You couldn't have survived there for an instant. An invisible rain of deadly particles poured out of the sun like a storm of razor-sharp daggers. As for the planet Earth, a thick, melty crust of boiling hot, sticky lava oozed across its surface. And to begin with, there was no solid ground, and definitely no life. The early Earth spanned so fast on its axis that each day was only about 4 hours long. What happened next was a total freak. Experts believed that two young planets were on the same orbit around the Sun but moving at different speeds. One was the Earth, and the other was a smaller planet known as theia. You can guess what happened next. Incredible as it sounds, about 4.5 billion years ago, so 100 million years after the Earth was formed, these two newborn planets smashed into each other. Just think of the force of two planets crashing together. Theia's outer layers instantly broke up into billions of tiny particles. They covered the Earth with a thick blanket of hot dust and rock. Volcanoes erupted all over Earth, and countless tons of gas that had been trapped inside the Earth's core blew out into the sky, making our planet's early atmosphere. Actually, it's just as well for life that on Earth that this great collision happened. Remember those tiny deadly particles that poured out of our sun? Well, the storm has never stopped. Even today, about 20 billion tons spew out of the sun in just 24 hours. This scary stuff is known as the solar wind. It can even go through the toughest spacesuits and hardest helmets worn by astronauts. But the solar wind doesn't hurt us on Earth. When Theia and the Earth smashed into each other, the huge shockwave fused the two planets' cores into one hot metallic ball. And ever since, this core has produced a magnetic shield that keeps the lethal solar wind away from our planet's surface. The shield also keeps the world from losing its precious supplies of water, which otherwise would have been blown into space. No liquid, no life. It's as simple as that. Today, there is no visible evidence on Earth of this dramatic collision. There is no crater because the force of the impact made all the outer material vaporize into space as dust. That dust wrapped itself around the Earth in a great cloud, which eventually stuck together, again thanks to gravity. Can you guess what this enormous cloud of dust turned into? Of course, it became our beautiful luminous companion, the Moon. The Moon has no metallic core, which means it's not protected from the solar wind, so there's no liquid there. It also has no atmosphere, which means no sound can be heard on the Moon, and the sky is always black and speckled with stars. Scientists are still unsure about lots of things to do with the early history of our planet Earth, and that's because the Earth has changed so much over time that there's nothing much left of that early time for us to study. But they can look at how the world works today and come up with some good guesses. Of all the planets in our solar system, Earth is the only one with such a large amount of liquid water. Why does our world contain so much water? Where did it all come from? Without water, life as we know it couldn't have developed. So these questions are important. Some experts think water came from deep inside the early Earth. Others have a much more otherworldly idea. They think that more than half of the world's water may have arrived on a giant storm of icy comets or asteroids about 4 billion years ago. Just imagine thousands of giant objects, some more than 160 kilometers wide, smashing into the early Earth. As they scorched through the atmosphere, the ice on them melted, producing vast amounts of water. All that water still exists today, and it's mostly in our giant global oceans. Well, that's something to think about the next time you take a bath. More than half the water in your tub possibly came from outer space. How and where did life begin? This is another question that scientists don't quite agree on. Some experts think the stuff needed by the first living things may have arrived on those comets or asteroids from outer space. Most of them think that life started somewhere deep down at the bottom of the seas. Even today, underwater volcanoes provide chemical food and warmth for teeny tiny living things. Back at the beginning of life on Earth, each of these life forms was just one cell. That's one tiny bundle of material that could eat, grow, and most importantly, split to become two teeny tiny living things. And that's one thing that makes life special, the ability to reproduce. As time passed, some single-celled life forms called cyanobacteria found a way to survive nearer the ocean's surface. They grouped together in shallow waters to make bumpy formations called stromatolites. They also used photosynthesis. This is the same process plants use today to turn sunshine, nutrients, and water into the energy they need to survive. Like all living things, the cyanobacteria gave off waste, but this waste was special. Cyanobacteria filled the air and seas with oxygen, completely changing the story of life on Earth. The technical term for things developing and changing and adapting to new environments is evolution, and we're about to see a lot of it. All this world changing took a long time. Let's leap forward to about 2.5 billion years ago. A new type of life called eukaryotes is now emerging. Eukaryotes use a special process called respiration. Respiration takes in oxygen to use as an ingredient to make energy. This marks another big change in the story of life. All plants, fungi, and animals are eukaryotes. And you might have guessed we humans are too. Imagine the Earth's history on a 24-hour clock. The Earth formed right at midnight. The first signs of life emerged at about 3 in the morning, but already we have travelled to just gone 1 in the afternoon. Amazingly, all the life on Earth that existed until this point were these life forms in the seas that were too small to see. That leaves only 11 hours, less than half the day, for the rest of all life as we know it to emerge. Now, remember how the Earth travels with the solar system around the galaxy? Unbelievably fast, far faster than any racing car. Well, we are moving in other ways too. The Earth is travelling around the Sun and it is spinning on its axis. And there's yet another kind of movement. You're sitting on a crust of rock that is very slowly drifting, like a giant raft on an underground sea of boiling hot magma. The same stuff that's called lava when it comes out onto the Earth's surface. With all this travelling and spinning and floating, nobody ever really sits still. The Earth's surface is divided into moving pieces. These pieces are constantly drifting apart or bashing into one another, like slow-motion bumper cars at a fun fair. It's a process we call plate tectonics, and the pieces are called tectonic plates. When continents riding on these plates collide, they form mountain ranges soaring high up into the sky, and when they drift apart, they form huge oceans or deep valleys. This gradual movement of the Earth's plates is so powerful that it creates earthquakes and volcanoes, geysers and tsunamis. There is an important positive side to this violent process too. The amount of salt in the seas has to be just right for life to survive. If the sea gets too salty, living things die. Thanks to the constant movement of the Earth's plates, salt gets buried deep beneath mountain ranges. This process removes salt from the ocean, leaving the saltiness low enough so it's safe for life. These moving plates also change the climate. Some scientists think that about 700 million years ago, moving plates plunged the Earth into a super cold ice age. This period is known as snowball Earth. Ice gripped the globe almost all the way from pole to pole. When the weather eventually warmed up again and the ice retreated, the story of life took a new turn. There were still plenty of microscopic life forms, but now larger creatures made of many cells began to join them in the seas. This leads us into one of the most amazing moments in our story. It is 540 million years ago. A quick check on our 24-hour clock shows it's now just after 9 p.m. There are still no plants, no flowers, no birds, no animals or humans. But finally, the first of the kind of life forms that will one day bring us into the familiar world around us are starting to appear. Fossils are the preserved remains of long-lost creatures or the impressions they leave behind. When creatures die, usually their bodies rot or dissolve. Sometimes, though, minerals in the ground near a bone replace the living cells in that bone, turning it into a fossil. And the same thing can happen to shells or teeth. Fossils are wonderful for helping scientists understand what kinds of creatures once lived on the Earth. Expert fossil hunters are called paleontologists. Charles Doolittle Walcott was a paleontologist. He was born in the United States of America in 1850. As a young boy, he found school quite boring. It wasn't that he had no interest in things, rather the opposite. He was so curious that he wanted to get outside and explore the world for himself, and in particular, he liked to look for minerals, rocks, birds' eggs, and fossils. One day in 1909, a freak accident changed the rest of Walcott's life. According to some people, he was walking high up in a remote part of the Canadian Rockies, and his horse slipped and lost a shoe. As the creature stumbled, its foot turned over a glistening rock. Walcott picked it up and saw rows of remarkable silvery fossils. These showed the perfectly preserved shapes of creatures dating back to a time known as the Cambrian period. Remember how the land is always moving and changing? Well, it turned out that the mountainside Walcott was standing on had been on the sea floor 505 million years before. Way back then, something, maybe a mudslide, had killed these creatures and preserved them like a time capsule. Walcott's fossils are now some of the oldest ever found, and the place where he found them is known as the Burgess Shale, named after nearby Mount Burgess. Walcott returned to the site many times and eventually wrote a shelf of books about his finds. And what a bizarre range of creatures they were. There were the strange-looking Amorlocaris, possibly the biggest hunter of its day. It could grow up to a metre long and used a pair of grasping arms to capture and hold prey. Another was Hallucigena. This little beast walked on tentacle-like legs. It used the spines on its back to protect itself from being eaten by predators. But nothing can prepare you for Opabenia. This ocean oddbod had 5 eyes, a fan-like tail for swimming, and a long nose with a mouth on the end. And there's nothing remotely like it alive today. One of the Cambrian period's most common forms of animal life was a group of sea creatures called trilobites, and their fossils range from the size of your thumb to 3/4 of a metre long and have been found all over the world. One very important thing about them is that they were possibly the first creatures ever to have fully developed eyes. And some experts think that trilobite eyes triggered a new race for survival in the ancient seas. They could choose what they wanted for dinner by looking around. And of course these creatures that were easy to see were the ones most likely to be for dinner. Hiding underground or being the same colour as the sea floor would have been a good way to survive in this brave new world. And this is a great example of how nature works and how new, better adapted creatures replace old ones over time. And the Burgess Shale creatures give us a glimpse into the very beginning of a time called the Paleozoic era. There have been lots of fossils found from this time, which saw an incredible explosion of life in the seas. Let's go on an imaginary dive to check out some creatures which lived in the first part of the Paleozoic era during periods called Cambrian, Ordovician, Silurian and Devonian. Before we start, another quick time check on our 24-hour clock of Earth history shows that this time lasts from 11 minutes past 9 to 8 minutes past 10 p.m. Sponges were among the simplest of all animals living in the ancient Cambrian seas. They are still alive today. About 5,000 different species of sponge have been discovered so far. For a long time, people thought sponges were plants, but actually sponges are animals. In fact, you and I are much more closely related to a sponge than to, say, well, a daffodil. Coral reefs are built over hundreds of thousands of years by tiny sea creatures. The corals grow on top of the skeletons of their dead ancestors. With their bodies, they create a rich habitat for other creatures. Today, up to 9,000 different species camp out. In the Earth's biggest coral reef, the Great Barrier Reef off the coast of Australia, it's made up of almost 3,000 individual reefs and stretches for more than 2,300 kilometres. The ancestors of today's corals first appeared in the Cambrian period. Jellyfish are related to corals, but nowhere near as friendly. They swim using a pumping action of their bell-like heads. Jellyfish have a very simple nervous system and only one opening, a combined mouth and bottom. Some can pack a nasty punch. They sting using an array of poison-tipped harpoons hidden in cells along their tentacles. Jellyfish were very common in the Cambrian seas. The ancestors of ammonites appeared during the Devonian period. Ammonites went extinct 65 million years ago at the same time as most dinosaurs. They look like giant snails, but their closest living cousins are octopus and squid. Ammonites had spiral shells to protect them against attack, and we know those shells came in handy. Their fossils have been found all over the world with teeth marks and scars. At first glance, sea squirts seem similar to sponges, but sea squirts have babies that swim around like tadpoles. They push themselves through the water with a special tail containing an early kind of backbone called a notochord. These creatures are still around today, but they first appeared in the Cambrian period. Sea squirts are thought to be distant ancestors of vertebrates, animals with backbones. Vertebrates include fish, amphibians, reptiles, birds, and mammals. And since humans are mammals, baby sea squirts are super important. Some experts think they should go down in prehistory as our great grandparents. Among the most fearsome creatures of the Silurian and Devonian seas was the now extinct placoderm. It was a giant fish that had jaws and teeth. Heavy armour plating covered its head and throat. Its body had thick scales, and some placoderms had fins covered in armour-plated tubes. These were nature's first war machines, built like tanks. A placoderm could grow up to 10 metres long and weigh over 4 tons. If it were alive today, it could easily snap a shark in two with a single bite. You wouldn't want to bump into a sea scorpion either. It had a long spiked tail that may have been equipped with a deadly venomous sting. This creature could grow to more than 2 metres long. Sea scorpions appeared during the Ordovician period and died out along with many other species in what's called the Permian mass extinction 252 million years ago. The Earth was formed 4.6 billion years ago. And life first appeared about 4 billion years ago. Now, it is 470 million years ago. The ocean is a busy place and home to our swimming and swaying, hunting and hiding ancestors. And the land, not so much. It's mostly raining.